Good day, students. In this clip, we're going to be going over two examples on how to find the average rate of change, the slope and equation of the secant line related to the function. I'm going to be showing you how to use the Ti-89 calculator to simplify the process considerably. Okay. All right. So let's go ahead and take a look at question number one. It says the height at time t of an object tossed in the air is given by the height function 10t minus 4.9t squared. Find the average velocity over the time interval from t equals 1 all the way to t equals 1.5. Write the equation of the secant line on this interval and sketch the curve and secant line. Okay, so you need to note that when you're talking about the average velocity, we're talking about the average rate of change over this interval. So think of velocity, average velocity as average rate of change. Okay, so the formula for the average velocity, let me show you, is average rate of change is also equal to the same formula for the average velocity. Average velocity, we're talking about the average velocity on the interval AB. Okay, so the formula for the average velocity on the interval AB is going to be h of b, the final time, minus h of the initial time, divided by b minus a. Okay, so this is the same formula as, you remember your slope formula in algebra 2, right? y2 minus y1 over x2 minus x1. So that's exactly what we're doing here. Okay. Um, all right, so there you have it. Okay, so what we're going to do now is determine how this formula um, applies to this situation that we're dealing with over here. Okay, so let's go ahead and write it down. So your um, average speed on, let's say, from 1 to 1.5 is going to be h of b, which is h of 1.5, minus h of 1 divided by 1.5 minus 1. Okay, what you want to note is that in this problem, a is equal to 1. The first value in the interval is a, and then the second value in the interval is b. Okay, so the b normally comes first when you input it into the function, minus h of a divided by b minus a as indicated in this formula. All right. Okay, so now there are different ways you can do this. If you want to do this by hand, you're going to do something like this. H of 1.5 is equal to 10 times 1.5 minus 4.9 times 1.5 square. And then you do the whole process. Well, this is a little bit complicated, so you might need a calculator. But H of 1 is a little bit easier. 10 times 1 minus 4.9 times 1 square. Okay, but with a calculator, let me show you how to make this process considerably easy. If you have a Ti-83 or less, you can uh, compute this process using this process right here, compute this value using this process. But if you have a Ti-89, let me show you a trick you can use. All right, and this procedure I'm showing you is also applicable to the Ti-89 titanium. Okay, so the one nice thing about this calculator is that you can create functions and you can store them. Okay, so what you do is you're going to use the F4 menu to define h of t. Okay, so you press F4. Option 1 is define. So define, type in h of t, alpha h, parenthesis t, t. Now you're typing in like that using alpha h and then the parentheses equal. Now you're going to type in what h of t is in the problem. Okay, so in this problem is 10t minus 4.9t. So it's going to be 10 t minus 4.9 t raised to the second power. Okay, press enter. It will tell you done. Uh, so what did it just do? What it just did is it stored this function in this assignment, this variable right here. So h of t, 10t minus 4.9t squared has been stored in h of t. Okay, so let's verify if our input is correct. So let's type in h of t and see what the calculator gives us. Okay, so we go alpha h parenthesis t, enter. Boom. It gives us the original function that we entered into it. It gives us in exact form. If you want it in approximate form or decimal form, you use diamond enter. Bam, this is exactly what we want. Okay, 10t minus 4.9t squared. Okay, so we have just started. Now we're going to start doing the computation. So we want to calculate h of 1.5t. So all you simply do is move your cursor to the right, go into the parentheses, delete t, and type in 1.5. Enter. That's a decimal. That's a fractional result. We want to deal with decimals here. So diamond enter. 3.975. You see, instead of typing all this process over and over again, you can just do it in one step. And I also need h of 1. Okay, so h of 1 is move the cursor to the right, go into the parentheses, delete 1.5, make it 1, press enter. I like decimal, so 5.1. Okay, so you see how we can quickly compute the output value of this function for multiple inputs just by changing the argument of our h of t function. Okay, so I'm going to put in 3.975 for h of 1.5 and 5.1 for h of 1, and then we'll compute the quotient, the resulting quotient. All right, so let's write that down. So we have h of 1.5 is 3.975, h of 1 is 5.1, and 1.5 minus 1 is easy to determine. It's simply 0.5. Okay? All right. Now we can compute this by hand, but guess what? Let me show you another cool trick you can do with your calculator. Not only can you determine individual functions, but you can also carry out operations on your functions. So I can type in this entire expression in my calculator to determine what the final answer is. Okay, so let me show you how to do that. So you do parentheses for the numerator, parentheses, let me go up to h of 1.5, minus, go up to h of 1, press enter. So that's the numerator expression here, divided by, parentheses in the denominator, 1.5 minus 1. Now you have to be really careful when you're entering long expressions like this in the calculator. You don't want to have a grouping error, so you have to separate the numerator and the denominator using parentheses to group them. Okay, notice how I grouped the numerator with the parentheses, and then I grouped the denominator with the parentheses. Okay, diamond enter. Now, also, after you enter an expression into the calculator, examine your pretty prints to ensure that the format is consistent with what you're looking for. Okay, notice how these two match perfectly. Excellent, that's what we want, and the answer is negative 2.25. The beauty about this is that it keeps your computation clean and you're less likely to make arithmetic errors, okay? So there you go. Negative 2.25 is the average velocity. All right, so let's write that down. It's going to be negative 2.25. Okay. All right, and the unit here, this is we're using metric unit, so it's simply going to be meters per second. Okay, meters per second. All right. So now that we have the average speed, the equation, the problem tells us to find the equation of the secant line. Right? Let's see. What does it say? Write the equation of the secant line. Okay, so equation of a line. So let's write out what we're looking for here, secant line. So what is the equation of a line? Well, if you want to find the equation of a line given a point and the slope, you use the formula y minus y1 equals mx minus x1. This is the point slope form of the equation of a line. Okay? So we need the slope. Guess what the slope is? The slope of a secant line is the value of the average speed, which is negative 2.25. Okay? And we need a point x1, y1. x1, y1. What we're going to use is we're going to use 1 and h of 1. You can use 1 and h of 1 or 1.5 and h of 1.5. It makes no difference, okay? So 1 is 1. What is h of 1? What do you get as an output when you input 1 into your function? Remember we did that earlier? H of 1 right here is exactly equal to 5.1. So h of 1 is 5.1. Okay? So this is x1 and this is y1. Okay? All right, so now we have all the ingredients we need to write the equation of a line. Let me just highlight it here. This is x1, y1. So equation of secant line coming up. So, the equation of the secant line is y minus y1, which is y minus 5.1, equals m, which is negative 2.25, times x minus x1. X1 is 1. Okay, so that's the equation of your secant line in point slope form. Okay? All right, now lastly, we are asked to sketch a graph of the situation, sketch a graph of the function, and also indicate, sketch the secant line there too. Okay, so to graph it, we're going to be making use of our graphing calculator. So let me just title what we're doing here, the graph. So what are we graphing? We're going to graph the original function. We're going to graph h of t, which equals 10t minus 4.9t squared. And then we're also going to graph the secant line, y minus 5.1 equals negative 2.25 times x minus 1 on the same coordinate system, okay? All right, so let's go ahead and enter the function into a calculator. So if you're at the home screen, you just press diamond F1 to access the graphing menu. Let's enter the function 10 x minus 4.9x squared. Okay, enter. Now you might wonder why am I not using t? Well, for the graphing menu, your independent variable is x. And in the function, the independent variable is t. So it doesn't really matter what you call the variable. But whenever you're entering it, the independent variable must always have the value of x. Okay? All right, so this is exactly the same thing. There isn't any difference. All right, so let's go ahead and graph. Wait a minute. Let me do this again. When you graph it, it should look like this. Okay, so there goes the function, the position function of the object that was thrown in the air. So I just want to zoom in on this area right here, from around 1 to 2, from 0 to 2, because we're graphing on the interval from 1 to 1.5. Okay, so let's zoom in a little bit on a portion that can enable us to draw a good graph. So I'm going to zoom in this area right here. So I'm going to press F2. I need a zoom box. I want to capture the upper left corner, set the upper left corner to somewhere there to the left of 0. And then scroll to the right. Remember, we're just making a sketch here. So I just want to get a good snapshot of what I'm going to sketch. All right, so that looks good. Enter. Okay, so that looks like a much nicer graph. So that is what my graph looks like. So let's see how high does it go. Let's trace it. F3 for tracing. It goes around like 5.0, 5.1. Okay, and then it goes from 1 to slightly above 2. All right, so let's go ahead and make a sketch using what we got from the graphing calculator. So there goes your y-axis. There goes my x-axis. I'm going to go by 4s here. 1, 2, 3, 4. That's 1. 1, 2, 3, 4. That's 2. I'm using that because I want my graph to be spread out considerably. Okay, so this is 1, 2, 3, 4, 5. I have my x with more tick marks per unit, so I can exaggerate my graph in the x direction. Okay, so it went somewhere above here, like there, and then it intersected somewhere here. Okay, let me see. I forgot what the left side looked like. Oh, is that 0? Okay, so 0 goes to 0. So just make a sketch of your function. It's nothing perfect, just a nice little sketch like that, and then That looks terrible. Let me do that again. And then it comes down through that point. Okay, so that's what it looks like. All right, now that we have the graph of a function of the function, let's label it. This is h of t equals 10 t minus 4.9 t squared. Now we also have to graph our secant line. Remember our secant line went through 1 and 1.5, right? So this is 1, and I use 1, 2, 3, 4, 1, 2, 3, 4. So this piece right here is 1.5. So we have 2 points. We have 1 point here. That's 1 and 3.975, and then 1.5. No, that's 1. And then we have 1.5 right here. That's yeah, this is 3.975, and then that's 1.5. Okay, yeah, it's more like it. Okay, so there you have it. So you have the 2 points, and then we just draw a secant line. So draw a secant line. Yeah, if we want to be exact, we need to bring the other point down a little bit. Because remember 1.5 was 3.975, so it's gonna be should be somewhere down here, but I didn't sketch it perfectly. So let's see. Okay, so let's make the sketch look something like this. 3.975 is 1.5, and then 5.1 is 4.1. Okay, so the secant line, let's just sketch the secant line, and then we're going to write down what the equation of the secant line is. So it goes from there to there. So there goes the graph of your secant line. Okay, let's change the color. All right, so let's make it blue, so dark blue like that. Okay, so there goes your secant line. Let's write down the equation. So this is your secant line, y minus 5.1 equals negative 2.25 times x minus 1. Okay, so there goes your secant line. And then the slope right here, that's what we calculated before. That's the average rate of change. Let's indicate that on our graph also. So see this triangle right here, from here to this point? That right there, this is your delta h of t over delta t, right? And that's your average velocity, which is negative 2.25 meters per second. All right, so there you have it. All right, let's take a look at question 2. And this example really helps you see the power of the formula that I showed you earlier, okay? So on this number 2, it has to determine the object's average velocity over the time intervals. 1 to 1.01, 1 to 1.001, 1 to 1.0001, and then to the left 0.9921, 0.99921, and then 0.999921. Use this to estimate the instantaneous velocity at t equals 1. Okay, so the goal is, can we actually determine what the speed of this object is at t equals 1 using what these left and right limiting values of the average velocity are? Okay, that's the question. All right, so what I'm going to do is I'm going to set up a table to help organize my data, and I will use the calculator to do the heavy lifting so I don't spend all my energy doing arithmetic, okay? All right, so on the first column, we're going to be entering the intervals, okay? So column 1, we're going to be entering the interval from A to B, okay? All right, and then on the adjacent columns, we'll be entering the value of the average rate of change, okay? So column on the second column, we're going to be entering the average average velocity. Remember, the average velocity is the same thing as the average rate of change, okay? So the average velocity is delta h of t, delta h of t divided by delta t, which is the formula h of b minus h of a divided by b minus a. Okay. All right. So let's go ahead and do the first interval, 1 to 0.1. I know 1 to 1.01, so we're gonna go from 1 to 1.01. Okay. All right. So the average velocity is gonna be average velocity is going to be, let's see, what is it going to be? H of b, b is 1.01 minus h of 1 divided by 1.01 minus 1. Okay? And then after we compute that, we'll enter the value on the last column I'm going to create right now. All right? So let's make a column for the value here. So value. All right. So whatever we get, we're going to put the value here. All right, so let's go ahead and do this. So this is for the first interval. So let's see. Um, let's see. Now, remember we already did define a variable, right? We're still working on the same problem. So let's call up what our function is. Alpha h of t is still saved there, okay? So we're going to be using diamond enter to get approximate outputs. All right, so I'm just going to input the formula right into the function. Oh, wait a minute. We already have it up here, so let me call that up. Um, well, let me enter it again just to make sure everyone is following. So we're going to go h of, well, we want to put the numerator in parentheses, alpha h of 1.01. Okay, remember how we did this? Minus alpha h of 1. Okay, that goes of the numerator divided by 1.01 minus 1. Okay, all right. So, yes. All right, so press enter. Bam. Well, diamond enter to get an approximate output. So it's 0.151. Okay, so the value is 0.151. Before I enter, let me go over it again to make sure it's correct. So h 1.01. Okay, h of 1, 1. Okay, because it looks good. So 0.151. Okay. All right, now let's do the next one from 1 to 1.001. All right, so we're going to have the average velocity is going to be h of 1.001 minus h of 1 divided by 1.001 minus 1. All right, let's calculate it. It gets, the more you do, the faster it gets, okay? It's slow initially, but later on it gets faster. So this is just add a 0 here. And then over there, add a 0. Diamond enter. All right, let's look at it, make sure it's correct. Okay, before we write down the answer. 1.001, check. 1.001, check, and 1. Good, so our answer is 1.951. All right, so the next row is 1.1951. 1951, okay, 0.1951. Without this trick that I showed you, it's going to take a really long time to calculate this, and it's really painful. But, you know, if you have the calculator doing the heavyweights, then it's easy to do, okay? All right, so we're going to shift to the next interval. We're going to go from um, 1 to 1.0001, okay? So going from 1 to 1.0001. All right, so the average velocity is going to be h of 1.0001 minus h of 1 divided by, let's see, 1.0001 minus 1. All right, okay, let's do that real quick. I get my calculator, put the 0 here, and then put a 0 there, enter. Oh, that one enter for decimal approximation. So 1.9951. Okay, 1.995, 0.19951, 0.19951. So you notice that as you were approaching 1, the number was getting closer to 1.5 something, right? Okay, so this is approaching 1 from the right hand side. What if we approach 1 from the left hand side? Okay, so we start from 0.99999 and 9999. What pattern can we see? Okay, so notice that as we're going in this direction, we're approaching 1 from this direction. The value is approaching something like 1.5, okay? And as you go away, it diverges from that value. So now let's look at approaching 1 from the left, okay? So let's see what that looks like. So if we're approaching 1 from the left, we're going to alter the value of a, okay? And it could be fixed at 1. So the first interval we're going to consider is 0.99, comma 1, okay? The average velocity here is going to be h of 1 minus h of 0.99, all right, divided by 1 minus 0.99, okay? We're going to make some changes to this function again. Okay, so bring up our calculator again. So now let's make significant changes to this. The denominator is going to change into 1 minus 0.99, and you have to check your entry after entering it to make sure it's correct, okay? And then b is 0.99, I mean a is 0.99, and then b is 1. All right, enter. Okay, before I rush to write down my answer, let me examine this first to see what this looks like. So this is 1 minus 0.99 over 1 minus 0.99. Excellent, so it's 2.49. All right, so let's enter it, 0.249, 0.249. Okay, we have 2 more rows to populate, so let's go ahead and enter them. All right, so we have, we're gonna go from 0.999 to 1. Okay, remember we're approaching 1 from the left side now, okay? All right, so we have 0.999 to 1. All right, your average velocity, which is the same thing as your average rate of change, is h of b, h of 1 minus h of a, 0.999. It's changed. That whole expression divided by 1 minus b minus a, which is 1 minus 0.999. Okay? All right, this should be quick to do. Fire up the calculator, bring up your calculators back. Just add a 9 to a, and then add another 9 to a there. Enter. Make sure that it's consistent with what we have here. Gotta be careful. 0.99. Okay, excellent. Looking good. So it's 0.2049. Okay, 0.2049. Let's enter that. 0.2049. All right, and last but not the least, we're getting closer to 1 from the left. We're going to look at 0.9999, comma 1. And your average velocity is going to be h of 1 minus h of 0.9999 divided by 1 minus 0.9999. Okay, all right, let's see what that is. Calculators, just add another 9. You see how quick the process is? If you're doing the same thing over and over again, this method, this trick is really, really powerful. Okay, all right, diamond enter. So let's check. We have 4 9s there. Good. We have 4 9s. This is 0.20049. Okay, 0.20049. All right. So we have 0.20049. All right. So when we're approaching 1 from the left, what do you notice happening? Is approaching 0.2. It's getting really, really close to 0.2. All right. So what does all this mean? Okay, actually, this is approaching. My arrow is going in the wrong direction here. So for this one, we have this arrow should be going in the other direction, so let's switch it around. Like that. So this is getting closer to 1 from the other direction. Okay. Alright, so what does this all mean? How can we approximate the instantaneous velocity? So to answer the instantaneous velocity question, I like to put all this together in a format that makes sense. So we have a line, and we have 1. We're approaching 1. Okay, we want to know what the instantaneous velocity is at t equals 1. All right, so what we did is we picked 3 values to the right, 1, 2, 3. The first one was 1.01. The other one was 1.001. And the other one was 1.0. Actually, let me switch this around. So we have, this is 1.01, 1.001, 1.0001. Okay, so this is getting closer and closer to 1 from the right. All right, so when we did that, this was the first one we had was 1.51. This was 1.51, and then this value is 1.951, 1.951, and then this value here was 1.9951. You see what this number is approaching? Can you make a guess what it's approaching? Well, let's go to the other direction, and then we can make a more informed guess, okay? So we also picked 3 values to the left of 1, okay? And then we asked ourselves, okay, if we get closer and closer to 1 from the left, what value is the average rate of change approaching? So we picked 0.99, and then 0.999, and then 0.9999. Okay, so for the first one we got 0.249, and then the next one got 0.2049, and then for the next one got 0.20049. So what do you think this value is? You see how what these two values are approaching? They're gradually approaching. Let me see. Okay, this is supposed to be 0. This is 0.99. This is 0. Let me do this again. Change these because I copied it incorrectly. So this was 0.19951. This was 0.1951. Okay, 1951. And then this was 0.15. Yeah, it's more like it. That's 0.151. All right, sorry about that. So what value are these two approaching? Can you tell? The value that they're both approaching is 0.2. So when you get an arbitrarily close to 1 from both directions, your average velocity is getting closer and closer to 0.2. So you can estimate that the instantaneous velocity, instantaneous velocity is approximately 0.2 meters per second. Okay? Because that's what these two values are approaching as you get closer and closer to 1 from both sides. All right? So there you have it. All right, so how well did you understand this problem and this whole process? Well, I want you to try this example. And in this comment section below, I want you to post your answers so I can know if you understood how to do it, okay? And let me know if you have any questions, comments, or concerns, just post it in the comment section. So for number 2, we have the function h of t equals, let's do 12t minus 4.9 t squared. I want you to do exactly the same process use this function to do exactly the same process that we did for number 1 and 2. Okay, so this will be basically number 3 and 4. So for 3 and 4, I want you to use this function. Okay, so use h of t for 3 and 4. Repeat the same process. Repeat. the same process. All right. Exactly uses exactly the same intervals I used for this, and then let's see what you get. All right. So there you have it. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here, and also post a comment to indicate your answers to the questions 3 and 4 that I posted. Or you can post any comments to let me know what you think about this presentation. More clues can be found at mathchef.com/calculus, or you can just scan this QR code for direct access. Thanks again for watching, and have a wonderful day.